So we're going to define the 6 trig functions to be able to find the ratios at any given angle. And so the first thing we're going to do is refresh our memory on what the 6 trig functions are in terms of opposite, adjacent, and hypotenuse. So first thing, let's go ahead and start writing out the trig functions. Okay, we got sine, cosine, tangent, and the other 3 are the reciprocals. We have cotangent, which is the reciprocal of tangent. Cosecant and secant are reciprocals of each other. And we can remember that by flipping the S and the C. And then we have the cosecant of an angle is the reciprocal of sine. Before we write the new definitions, we have to come up with the old ones. The old ones are going to help us know what the new ones are. So we're going to start off with SOHCAHTOA. Sine of an angle corresponds with SO, which is the opposite over the hypotenuse. And then the cosine of an angle corresponds with CA, which means we're looking at the adjacent over the hypotenuse. The tangent of an angle corresponds with TOA, which is the opposite over the adjacent. TOA. Now you guys, the other 3 are reciprocals of the first 3. Cotangent and tangent are reciprocals of each other, and that's easy to remember because the word tangent is within cotangent. And secant and cosecant are reciprocals of each other, and we remember that by flipping the S and the C. So we have the hypotenuse over the adjacent. And then we flip the ratio of sine to get cosecant. So we're going to draw a triangle in the first quadrant here. And this is our theta value. And if this is theta, this side over here is opposite. This side over here is the adjacent side. And this side here is the hypotenuse. Now you guys, we're going to rewrite each one of these 6 trig functions in terms of x, y, and r. So we need to figure out the placement of x, y, and r right now. The adjacent side corresponds to the side-to-side movement, the horizontal movement. And that is what? Corresponds to x. The opposite corresponds to the up and down movement. Vertical movement is y. Now you guys, if we were looking at angles going all the way around this circle here, if we were looking at angles going all the way around the 4 quadrants, we could make a circle, right? And so we write the hypotenuse is the r value. Now all we need to do is replace opposite, hypotenuse, and adjacent with the x and the y and the r values. You guys, if you can remember SOHCAHTOA and come up with the first 3 and know the last 3 are reciprocals, and if you can remember your triangle corresponds to adjacent x, the opposite y, hypotenuse r, you can come up with these 6 trig functions pretty easily. It's very important to memorize these definitions, okay? You have to have these definitions memorized. That's really important, okay? So let's get started on a problem. So example 3 on page 374 says, let theta be any angle in standard position whose terminal side contains the point -5, 3. Find the 6 trigonometric functions of theta. So let's come up with the setup to start. Here we are at -5, 3, and we're told that let theta be on the terminal side of that contains the point -5, 3. So we've gone from our initial ray to the terminal ray here, which is creating this angle here. So this angle takes us to -5, 3. And we want to come up with the 6 trig functions at this point. So what we want to do is come up with r, because we have x and y. We have x, y, we want to come up with r. How are we going to come up with r? Any ideas? I drew a right triangle there. We know that this side here is -5, this side here is 3. So what can we do to find out what the r is? Pythagorean theorem. So the Pythagorean theorem says that 3 squared plus -5 squared is going to give us r squared. So we know that 9 plus 25 is 34. That's equal to r squared. If we take the square root of both sides, that gives us r. Now, you guys, we have x, y, and we have r, which means that we have everything we need to write the 6 trig functions. Let's go ahead and write them out. We know sine corresponds to y over r. Y over r. So that means we have a 3 over the square root of 34. I'm going to rationalize my denominator, and that will give me 3 root 34 over 34. Cosine of the angle corresponds to x over r. So we're looking at -5 divided by the square root of 34. And if we rationalize our denominator, we end up with -5 root 34 over 34. So far, so good? No?
Yes.
Okay. Tangent corresponds with y over x. Y over x means that we're looking at a 3 over -5. The other 3 are reciprocals. And we have our 6 trig functions. You guys have any questions? What I'd like you guys to try doing right now is, in your homework, start on number 7 and make sure you understand that kind of problem. I'll come around and help you. All right, so now we're going to find 6 trig functions at a specified angle. Previously, we were given an xy coordinate, and we had to come up with the r value. Now, we have to come up with x, y, and r based off of an angle value. And so we're finding the 6 trig functions at 315 degrees. So let's think about where 315 takes us. This is 0. This is 90. This is 180. This is 270. And then all the way full circle takes us to 360. So we are going to be in the 4th quadrant here because we're at 315, right? And so we go all the way around to, boom, right there at 315 degrees. We're at 315. So from here, at 315, we're going to go straight to the origin. And that's going to represent our r value. Now from here, we're going to drop straight down to the x-axis. Dropping straight down to the x-axis gives us a right angle. And from here, let's figure out what kind of an angle is going to be in the pocket here, right next to the origin here. How far away is 315 from 360 degrees? 45. So this is 45 here. And this is 45 here. And that means that we can write the different sides and based on a particular hypotenuse. Last week, we talked about constructing a triangle with a hypotenuse of 2, right? So if we have a hypotenuse of 2, what are these 2 legs equal to? Square root of 2 is here, and the square root of 2 is here, except because we're in the 4th quadrant, and this side corresponds to up and down movement, we're talking about a negative square root of 2, right? So you can think about this point here as the square root of 2 comma negative square root of 2. So that's our x and our y value. So from here, you guys, we have the sine of 315 degrees. The sine of 315 degrees corresponds to y over r. So we have negative root 2 divided by 2. sine of 315 is minus root 2 over 2. So let's go to cosine. The cosine of 315 degrees corresponds to x over r. The x value is the square root of 2, and that's over 2. And then we do tangent. Tangent is equal to, tangent of 315, I should say, is equal to minus root 2 over plus root 2, which gives us a negative 1. The other three are reciprocals. I'm going to pause it. My question is, will I get the same exact ratios if I constructed with a different triangle? If I used a hypotenuse of 1, would I end up with the same exact ratios? Absolutely, absolutely. If I used a hypotenuse of 1,000,000, I would end up with the same exact ratios. Okay? All right? The reason why I like using a hypotenuse of 2 is because it tends to work out a little bit more nicely that way. I don't have to deal with fractions and inverting and multiplying and whatnot. Okay? All right, so this next one, example 5, we have to find the sine of negative 210 degrees. That's part A. There's a B and a C as well. So remember that when you have negative angle measurement, you go clockwise. So now we're looking at going from 0 to negative 90, negative 90 to 180, and then right here this is negative 270. So that means that this angle placement is going to take us to the second quadrant, right? This is right here, this is where negative 210 is located. So from here, what I'm going to do is I'm going to go back to the origin here, and I'm going to drop down to make a right triangle. Drop straight down to make a right triangle. And I'm going to erase this here. Okay? So what we want to do is we want to figure out the distance from negative 180 to 210. What's that distance from negative 180 to 210? It's 30, right? So that means that we're looking at a 30 here. And if that's 30, this is 60. And we're looking at a 30, 60, 90 triangle. If this is 2, if the hypotenuse is 2, or the radius for these new definitions, what do we know about the side opposite of 30? The side opposite of 30 is 1/2 of the hypotenuse. That means that this side here is equal to a 1. Now you guys, if I were to use the Pythagorean theorem, I would end up with the square root of 3 for this side, but this is a negative root 3 because we're in the second quadrant here, and we have negative x values in the second quadrant. Now you guys, we have the sine of 210, negative 210, which corresponds to y over r, and now we have a 1 over a 2 there.
Go.
We're going to find the tangent of 5 pi over 3. Now you guys, it might be a little confusing at first because we're dealing with radians here. And we want to convert this into degrees. What do we know pi is equal to? What's pi equal to? 180. So let's go ahead and say we have 180 divided by 3, which is equal to 60. So that means that we're looking at the tangent of 30 degrees. We're looking at the tangent of, not 30, 300 degrees. So that takes us to the fourth quadrant. So 300 degrees takes us all the way around to the fourth quadrant. Boom, right here. This is 300 degrees. And I'm going to go back to my origin, and then I'm going to drop straight down to the x-axis to create a right triangle. And then from here, I want to figure out what the distance is from 300 to 360 is. What's the distance from 300 to 360? 60. So we're looking at another 30, 60, 90 triangle. If this is 2, the side opposite of 30 is half of the hypotenuse. And then the side over here, this one's going to be a minus root 3, right? So tangent's definition corresponds to y over x. And we have our point, which is x1, comma, y is negative root 3. And so we end up with a minus root 3 over 1, which is just minus root 3. And looks like I'm running out of time here, so we're not going to be able to get to part C or example 6.